Balancing redox reactions. Let's look at how to balance a half reaction with electrons. Remember, electrons are negative particles. Also, we'll start with the simple and go to the more complicated half reactions. In this example, tin goes to tin 2+. Remember, electrons are negative particles. In order to balance this equation, 2 electrons are required on the right-hand side, on the product side. Because it's on the product side, this is an oxidation half reaction. Here is another example of Br2 bromine goes to the bromide ion. In this case, before balancing the electrons, balance the atoms. And after doing this, we'll need 2 electrons on the reactant side, and this is a reduction half reaction. Balancing redox reactions with oxygens. Remember, electrons are negative particles. Here's an example of balancing a redox reaction involving oxygens. Iodate, IO3- ion, goes to I2, iodine. There are steps to follow, and following these steps will lead you to successfully balancing these half reactions. Step 1. Balance the atoms that are not oxygen or hydrogen. Step 2. Balance the oxygens with water. There are 6 oxygens on the left, and this requires 6 water molecules. Step 3. Balance the hydrogens with H+. For 6 water molecules, 12 H+ are necessary. Step 4. Balance the electrons. The total number of electrons, 12 plus minus 2, is equal to 10 plus. So 10 electrons are required on the left side. And the final balanced equation is a half reaction that is a reduction half reaction. Here is an example to try. MnO4- is called a permanganate ion, and it goes to Mn2+, the manganese divalent ion. The answer to this is given here. Balancing redox reaction by the half reaction method for a full equation. Here's an example reaction that needs balancing. It can be done in an acidic solution or basic solution, and often this will be indicated acidic or basic. The dichromate ion Cr2O72- reacts with nitric oxide NO to give chromium ion Cr3+ plus the nitrate ion NO3-. The pre-step before the steps to balance the equation is split the reaction into half reactions where the half reactions have similar chemical species. Then follow the routine steps for each half reaction. Step 1. Balance the atoms that are not oxygen or hydrogen. Cr2O72- goes to 2 Cr3+. Balance the oxygen with water. This requires 7 water molecules as a product because there are 7 oxygens from the chromium 2O72- ion, the dichromate ion. Step 3. Balance the hydrogens with H+. There are a total of 14 hydrogens that are on the right-hand side, so you require 14 H+ on the reactant side. Step 4. Balance the electrons. Repeating the same process for the other half reaction, here is the answer is 2 water molecules plus NO gives you the nitrate NO3- plus 4H+ plus 3 electrons. The next slide will show how to sum these equations to give a net final balance equation. Balancing redox by the half reaction method continued from the previous slide. Sum the 2 half reactions and make sure electrons cancel. The common number of electrons for both reactions is a total of 6 electrons. In order to obtain this, multiply the entire oxidation half reaction for the nitric oxide by 2. This gives 4 H2Os, 2 NOs as reactants, and 2 NO3- plus 8 H+ plus 6 electrons. Summing these 2 half reactions will now allow you to cancel the electrons because the electrons gained is equal to the electrons lost in redox reactions. Now cancel the reagents that are common on both sides of the chemical equation. 4 water molecules is cancelled by 7 water molecules with a net of 3 water molecules on the product side. 14H plus on the reactant side cancels the 8H plus on the product side with 6H plus remaining on the reactant side. This will then give the net balanced equation. The next slide will be a check to make sure the balancing process was correct. The purpose of this slide is to show that you need to check to see if the equation is balanced. Balancing all the atoms and the charges is necessary. Final questions that will be asked are what element is reduced and what element is oxidized. Chromium is reduced and nitrogen is oxidized. What is the oxidizing agent and what is the reducing agent? The oxidizing agent is Cr2O72-, the dichromate ion. Nitric oxide, NO, is the reducing agent.